On the back side of the notes, what we have is the complement of an event. So for these, like up at the top here, we're going to have kind of unfavorable over total. It'll really be the same thing as we did on the front. Just with the complement, we're going to have like the word not thrown in there. So with the first, what's the probability of not rolling an even number on a six-sided die? So again, with my probability, so I know that my totals, I have 6 total possibilities, 1, 2, 3, 4, 5, and 6. And then if I don't want it to be an even number, all the numbers on a six-sided dice that are not even would be 1, 3, and 5. And so I've got 3 possibilities that are not even and 6 total. And so I have 1/2, which is 50% still. With the second one, again, I want to find out the probability of not getting a Dr. Pepper. So with my probability of getting not Dr. Pepper, I know I have 50 total pops. And then one of two ways I can go through here. I can count and add together all the ones that are not Dr. Peppers. So add the Pepsis, the Diet Cokes, and the Big Ks together. Or if I know if I know there's 10 Dr. Peppers and 50 total, I can subtract them to get 40. Know that there are 40 that are not Dr. Peppers, which reduces down to 4/5, which is 80% or 0.8. And then with this last one here, probability of not spinning a number, that's 3 or less. And so again, probability of not 3 or less. Again, I still have 8 total possibilities here. If it's not 3 or less, that means it's 4 or more. And so I've got 5 possibilities there with 4, 5, 6, 7, and 8. When I divide those by each other, 5 divided by 8 gives me 0.625, which is 62.5%. The next things that we have are experimental probability. And so again, that's just talking about the number of times something happens in like an experiment divided by the total times that I did the experiment, or I'll say, trials, the number of times that I tried it. So the first one, again, quality control inspector samples 500 total LCD monitors and finds defects in 3 of them. So what's the experimental probability that a random one will have a defect? So again, the probability of defect, so again, total number of times something happened, total number of times that I found the defect was 3, and then the total number of products that I sampled was 500. When I do that, I end up with, let's how we go, 0.006, which ends up being 0.6%. And so what I want to do is I want to apply that probability there to figure out, of all these monitors, how many are likely to have a defect. So I can go 0.006, multiply it by the number of monitors, which was 15,240. So I do that times 15,240, get 91.44, so about 91 monitors will have a defect. Same thing with this last problem here. It says a park has 538 trees. Choose 40 at random and determine there are 25 maple trees. So when it's talking about the experimental probability that a tree chosen at random is a maple tree, so the one thing we need to be careful with here is when I'm finding my probability, the total number of trees that I actually checked was I checked 40. So make sure that 40 is my total, and then 25 are maple, so 25 are going to be in that. You're going to be what I was looking for. And so again, 25 divided by 40, I could get 0.625, which is 62.5%. And then it says how many trees in the park are likely to be maple. So I can take that 0.625 and multiply it by the number of total trees, which is 538. and that gives me 336.25. And so I can say about 336 trees will be maple trees.